Hey, welcome to Ones and Zeros. My name's Ben, and today we are doing the first in a bunch of sort of individual videos where we're going to be going through and taking a bit of a look at some of the basic peripherals in the STM32 series. So in this stream or video, we are going to be taking a look at external interrupts and having a bit of a look at the way I find is the simplest approach for actually getting them working. And then we're also going to have a bit of a look at writing a driver, which allows us to sort of go through and set up interrupts nice and easily, so that we can use them a bit more flexibly in some of our other projects. So whereas in our Discovering STM32 series, we've been using the STM32 F7 discovery board with the LCD and SD RAM and flash memory and all of that sort of stuff on the board. We're going to be taking a bit of a look at something a little bit simpler for some of these individual videos, using a device that is a little bit more accessible and also a little bit similar to, say, if you were to get a blue pill or something like that. A lot of this will be easily usable for that sort of stuff as well. So if we have a look at this guy, this is what we're actually going to be using for the few videos where we go through and take a look at these bits and pieces. So like I said, looking at the external interrupts for this video, we'll also go over the next few days going to be doing videos where we are looking at doing various stuff with timers. So be doing a video where we basically look at setting up a timer so that we can trigger interrupts at regular intervals, whether we want that to happen continuously or say if we wanted it to happen 5 times or 10 times or something like that. We'll be showing how to do that and getting a driver written up for that. Also be looking at things like using encoders with timers so that the timer can actually allow us to use the encoder much more easily. And then on top of that, we'll also be doing PWM with timers as well. Sorry, just making sure Twitch is behaving as far as the stream. Okay, cool. So encoders, PWM, there will also be a few videos coming up where we use some of the other features of timers as well, because they're probably the most flexible peripheral in the STM32 devices. And we're also going to be looking at things like the analog to digital converter. If you're using a device that has a random number generator, we'll be doing a video on that. We're doing videos on things like real-time clock, using watchdog timers, all that sort of stuff. So basically going through and doing a little video on each of those bits and pieces as well. Now, the code that we do use today is actually based on the code that we're doing in the Discovering STM32 series. It's basically just being converted across just the basics of it for the F4 Nucleo device. So anyone that's seen the first episode or any of the episodes from the Discovering STM32 series, you'll probably be a little bit familiar with the code layout. And we can see that I've brought across the Gpio driver as well as the UART driver and the serial system. So all that stuff is already ready to go. I'll be making this code available on GitHub for anyone to download. That'll be available from not long after the end of this stream. And a lot of the code that we look at over the course of these videos will be being made available on GitHub. I will also be porting this code over to the F7 discovery code that's already available on GitHub as well. So that's going to be usable for anyone regardless of which device. So I'd like to get to a point where we've got H7, F7, F4, and F1 code bases available for people to download from GitHub. So regardless of which sort of device you're using, might even look at doing F3s as well if I can get my hands on some of those. As some of you have pointed out, they're not the easiest things to get hold of at the moment, unfortunately, but thankfully most of the ones that we're going to be using in the videos are ones that I've had laying around for a while. So that way we can at least get this stuff out there and people can sort of see what's happening with that. So at the moment, basically all the code is doing is going through setting up the user LED, so the green LED that you can see flashing on the board. We're also setting up serial device as well, so that we can start sending stuff back to the serial terminal on the laptop and just sending a string saying that the device is booting. And that's basically all there is for this at the moment. Again, all of this is basically identical code to what we've been looking at for the F7, just been moved over for the F4 using similar process to what I did in the first episode of the Discovering STM32 series. So let's get into some code. What we're going to do first up is basically just in our main function, set up a bit of an external interrupt, just hard-coded, just so that we can see sort of how that works, how I go about setting it up, because I do it a bit differently than the way the HAL typically sort of shows it. If we have a look in our HAL driver, we'll actually see that there is a particular HAL driver just for external interrupts, and for the most part we're not going to be using any of that. I find that there's a much simpler way to do that, so let's get stuck in and we'll see how we go about that. So first things first is, for testing over this video, we're going to be using the user button, this black one. Might help if I switch to the right, CNIT, not OBS. That one there. So we're just going to be using the black button. So the blue one is our, blue one is the one we're going to be using. The black one is our reset button. So we're just going to set up external interrupt to the blue button, which means that what we're going to need first up is the particular GPIO and pin number that is connected to. So in this case, it's going to be GPIO C pin number 13. So if we jump into our setup, there's one I've prepared earlier. So much like done previously for user LED, like we did with the Discovery series, and just popping in a couple of defines just so that we've got those ready to go, just to make life a little bit easier. So let's just pop a comment in there just to help separate out some of that code a little bit. And first things first, we're going to look at actually getting the external interrupt set up and working initially. So the way I'd approach this is firstly by setting the GPIO up, and for that we're going to need a GPIO Unit type def, and we're just going to call that guy GPIO Unit, fill it with zeros. We're going to pop in there our QAD user button, GPIO pin. I'm going to want set our mode for that one. So in this case, we're just going to get the interrupt to trigger on the rising edge of the signal. So that will occur when the button is pressed. And then there'll also be a falling edge when the button's released as well. And we could set it up to trigger on that one, or we could select for it to do on both of them. So when we press the button and when we release it. So there's a few different options. And when we go ahead and write the driver for this, after having a look at sort of the simple approach, we'll set it up so that the driver can be defined for each interrupt to trigger how we would like it to. So in this case, we're just going to tell it we want GPIO mode IT rising, so that the mode is interrupt, and on the rising edge, we'll want to set no pull up or pull down. Set our speed. And let's initialize that. So HAL Gpio Unit. Our Gpio is the one we've defined in Gpio user button, Gpio port, and we'll just pass it a pointer to our Gpio init structure. So that's the Gpio initialized. Now, we're also going to set up the interrupt as well. So set up for the nested vectored interrupt controller. In this case, because we're using pin 13, the particular interrupt that we're going to use will be the EXTI 15_10 interrupt. So if we have a look at our startup file, pop this guy back over here, make a bit more room so we can see what's going on. If we scroll down a bit, we can see for 0, 1, 2, 3, and 4, these guys have their own individual interrupt handlers. There's then one for EXTI9_5, which means that pins 5 through to 9 on any of the GPIOs share the same IRQ handler. And then we also have one for pins 10 through to 15. So in this case, because we're using pin 13, it's going to need to use this interrupt handler. So that's the one we're going to be working with in this case. So we'll set the priority for this one. And I'm just going to go EXTI 15_10_IRQN. We'll set this to A in hex or 10 in decimal, and just pop a 0 in for the last one just because of how we have our priority set up. And we want to enable that interrupt, and that will just be the same here. So and it's literally that simple to get an external interrupt set up. So it can sometimes seem a little bit daunting. I find when I first took a look at the EXTI driver in the HAL, it's way more confusing than it actually needs to be, because these are basically the two steps that we need to do, is setting up the GPIO and then setting up the actual interrupt itself. So we're going to go into our handlers file, and we also already have that one set up there, which means I have some leftover code in here from when I was playing around with this the other day. Get rid of that. So this is our interrupt handler that's going to be triggered whenever we press the button. And what we're going to do in here is we'll make the most of the fact that we've already got our serial accessible from in here. So I've basically got this guy, which is being set up in our main.cpp file. Just got an external declaration of that, which we're using when the serial IRQ handle is being triggered from USART2. And we're just going to reuse this and just use it to send a string just to say, let's go interrupt triggered, just so that we can get a bit of a representation on the computer of when that interrupt is actually being triggered. So let's build this and make sure that that's actually going to build okay for us. All right, let's get that popped onto the device, and we're also going to set this up with the right port, might help. That's a bit better. And just reset that one. I just want to make sure something not right there. Ah, I know what I've forgotten. So over here, we need to be firstly checking if that was pin 13. So we need to check that the interrupt is being triggered for that pin specifically. If it is, then we can send our serial data, and if so, we want to then clear that one, which is why we were getting all of that scrolling text. So that's basically because we weren't clearing the interrupt flag there. So if we pop that on there, still not behaving the way I would like it to. Let's just disable that one for the moment. Just want to make sure that the basics of that is actually functioning correctly. Okay, so showing us it's booting correctly. Okay, we'll disable that interrupt. Let's jump to that one and see. Okay, excellent. So we're not getting all of that streaming data this time, but it did come up saying it's booting. Let's try our button. Excellent. So press the button and we can see on the serial monitor, it's letting us know that the interrupt was triggered. Like so. And then, as I mentioned, we can get it to do it on different edges. So at the moment, it's occurring when I press the button. If we jump back into here and we change this guy to IT falling and pop that on there, we can then get it to trigger when we let go of the button rather than when we press it. Okay. Like so. So that is the basics of how to get external interrupt set up. Now, like I said, now that we've sort of seen how that works a little bit, let's get a driver written for it that allows us to a little bit more flexibly get various external interrupts set up and working as we'd like them to. So just going to remove that for the moment. And let's just comment this code out. So we come back in and change that shortly. Close those guys, and we're going to jump into our drivers folder, and we're going to create a header file and a source file in here. So just call that QAD EXTI HPP, and we'll create a CPP file as well. And much like we've done for a lot of the F7 series, we are going to go through and create this as a class. You could just do it using just C code if you'd like to. That's certainly an approach I've done probably more times than I've used C++. But I find doing it with classes makes code a lot more reusable, a lot more easily. Although technically everything that you can do with classes, you can do using C code anyway. Now, what we're going to do with this one is we're going to do it as an extension to our Gpio input class here. So we're going to create our external interrupt class so that it inherits from this one, so that essentially when things first get set up, it's just acting as a standard Gpio input that we can check to see what state it's in, but we can then have the ability to turn on the external interrupt or turn it off as needed, and basically switch it between being a standard input pin and being an external interrupt pin. Just to provide a bit more flexibility, and so that you can kind of see how we can go about doing that as well. So let's create the class for that one, and that will be inheriting from QAD Gpio input. Now we're going to create an enum so that we can select what type of edge we're going to be working with. So we have rising, falling, and let's just call that both. All right. Now, need to be able to keep track of whether or not the external interrupt is active. So I'm just going to use a QA active state enum for that one. And we'll just call that EXTI state. I need to track what edge type we're actually using for that one. So pop that one in there. It's also handy to keep track of which IRQ we're using. Just makes enabling and disabling things a little bit easier. So I'm just going to pop that one in there. So the IRQ N type is basically the EXTI15_10 that we used before when we were setting up the NVIC. And so that we can have a bit more flexibility with how things are triggered. When the interrupt is triggered, we're going to get that interrupt to call a handler method inside this class, and then we'll have it so that we can actually link up either a function pointer or a particular class to this EXTI class in order for it to then trigger that for the interrupt, which may sound a little bit complicated initially, but it will make a little bit more sense as we go on as well. So what we're going to do up here is we're going to create what we need to be able to do our function pointer. Now we might actually pop these guys in setup, because these might be things that we can use for other stuff that we're going to create as well. So let's pop them in here. So this will be QAD IRQ handler callback function, which will be the function pointer. So this allows us to either use a function pointer or a class, or both if we would like to, as far as triggering our interrupt from our EXTI class. And we might make this so that it can be given a void pointer if we need to pass anything to it. So that's our function, and we'll make a class for this as well. Like I said, these will make a little bit more sense as we go on as well. So once you see sort of how we actually use these. So in this class, we're just going to put one method, which will be a virtual or pure virtual function. Same again, we'll allow it to be passed a void pointer, just in case we use it in a situation where it needs to be passed something. So what it's basically saying is anything that inherits from this class needs to at least fulfill this handler method, which is what will get called from the EXTI class. So back in our EXTI header file, we're going to pop a couple of bits in here to be able to store that function pointer and the class as well. And in the case of the class, it'll actually store a pointer to the class, like so. Now let's get our constructor and destructor done. We're going to delete our default constructor, because we're going to want this to actually get past a bit of information for it to be able to be set up correctly when it gets created. So we're going to create a constructor here, which is going to take we'll take the particular GPIO that we're actually using, as well as the pin that we're using. Go through and initialize our member variables. Set our state to inactive by default. I'm actually going to set our edge type initially. We will, however, set our handler function and our class to both to null. And that will do for the moment. Now we are also going to make use of our destructor as well. Not going to pop anything in there at the moment. The other thing I forgot in here for this constructor is it also needs to call the constructor for the class we're inheriting from, so our QAD Gpio input. So in that case, we can just call QAD Gpio input, and that also needs to be given the GPIO and the pin from that. So that way when this constructor gets called, it's going to go through and call this constructor here to actually set up the GPIO as an input initially. So that's those for the moment. We're going to pop in a handler method. So this will be the actual method that gets called by the interrupt handler in our handlers file. We're going to want some control methods. So going to want to be able to set what our handler function is. And another one so that we can set our handler class. Needs to be a pointer to that one. And we want some methods to enable and disable the external interrupt as well. So with our enable, that's where we tell it what edge we actually want to use. And if it's already enabled and we want to change which edge we're triggering on, we'll make it so that we can just call enable again without having to first disable it, just to keep things nice and simple. So go with that for the moment. Also going to need to, might help if we fix up all of this stuff as well. That will be EXTI, so 17th. And we also need to do our prevent recursive inversion inclusion down here. Inversion. Words aren't working properly. Like so. So let's grab that stuff. We're going to copy this over here. Get rid of that one and that one. This needs to include our EXTI header. Grab our function declarations here. And also just going to change that to CPP so that that's correct. And grab some coffee. Wonderful. Go through and get these guys done as well. Make sure we're using the same consistent formatting that we've used for all the rest of the code. Also need to pop in that prior to the edge type as well, just because currently outside of the class, so it needs to know that that's actually referencing something that is inside the class. And quickly pop the names in here as well. It sometimes be a bit annoying having to go through and do all of this stuff, but if you get the formatting all neat and tidy initially, it just makes life so much easier. So let's get these guys sorted out. Now, I have gone through and previously from the Gpio driver that we wrote in the Discovering STM32 series, this was actually private. So I've changed that to protected, which still means that it's not visible to anything outside of the class, but it does now allow anything that inherits from this class to access it, so that these methods here and anything inside of this class can actually access our GPIO and our pin, so that we don't have to store them separately in the EXTI class. So in our handler method, much like we did before, we're going to go helm GPIO EXTI get IT, and then because we've got that stored in our GPIO driver, we can actually just access that from here. And I'm just going to go helm GPIO EXTI clear IT and pass it mu pin so it knows which pin. Now, as far as our handlers that we've set up, so our handler function and our handler class, the way we're going to use those is it's firstly going to check to see so for the function, if it's null, because if it's null, we don't want to call it because we're going to cause most likely a hard fault exception. We want to avoid that. But if it's not null, then we can assume that there's actually a function there, in which case we can call that. And in the case of our handler class, we can actually call the handler method that is in there, and we'll just pass both the class and the function null for the moment. So that's basically the handler done. So this is the bit that will actually get called from this interrupt handler routine or function. Okay, so these guys will be fairly simple because we just want to go and for this one, going to be fairly similar. Brain's not working. P handler. So that will allow us to store our class, and then we've just got to go through the more complex bits of being able to enable and disable the external interrupt. So for this, first thing we're going to do here is actually store our edge type so that we've got that for future reference. We call that just edge, or do we call it edge type? Call that edge type. Cool, so that's got that stored. Okay, so set up the GPIO for this one. So at this point, it's already set up as an input pin. So we're basically going to reinitialize it so that it now acts as an interrupt rather than just a normal input pin. So much like we did before when we took a simple look at it when we did it in the main function, I'm going to go through and set up a Gpio Unit type def, pass the bits to that we need, so that'll be mu pin being pulled up or down. And we're going to set our speed. Now, we're going to use a switch statement to, based on what type of edge we've selected, rising, falling, or both, to put the correct value into the Gpio Unit structure. So for that, just going to go switch based on the ME edge type. So if it's a rising edge, with rising, if it's falling, and if it's both, then we'll set it to Gpio mode IT rising underscore falling. Like so. So that's all of the info that we need in that Gpio Unit structure. So let's just go and initialize that. We'll pass it the particular GPIO, which is stored in the GPIO input class that we're inheriting from. And we'll pass it a pointer to that Gpio Unit structure. Now, we also need to determine what interrupt we're going to be working with, whether it's 1, 2, 3, or 4, 5 to 9, or 10 to 15. So it'll be one of those 6 depending on which pin number it is. So for that, we're going to create a switch statement for that based on its pin number. So if it's pin 0, then we want to use the EXTI 0 interrupt handler. And we're just going to store this in our M_E IRQ so that we can reuse it and not have to recalculate it later on. So we'll do this for our first 4 pins, which all have their own individual interrupts. And we're going to do it a little bit differently from 5 through to 15, because 5 to 9 and 10 to 15 are using those shared interrupts. So we'll go default. If pin is greater than or equal to pin 5 and it is less than or equal to 10 or 9, more correctly. And we're going to do that interrupt, but otherwise, if it's 10 through to 15, then we'll use the other shared interrupts. Should be 15 to 10. I don't know why they have those numbers backwards, but that's just the way they've done it, so we'll go with that. And then, much as we did before, just a matter of setting our priority for our required interrupt. We're just going to go with a hard-coded priority value for the moment. Actually, we might go with B just so that we give it a, make sure that we're giving it a lower priority than our UART interrupt. Enable the IRQ. And at that point, we will be active. Now, for this priority level, we might actually store that in our setup. Okay, so again, got one I've prepared earlier. So just going to grab that and pop this in here. So that way, if we want to come back and change that, we can do that in the setup file with all of the other priorities that we've got stored in there. Just so that everything's all in one place and nice and neat. So that's how we go about enabling the interrupt. And then we'll just do the code to disable it. Firstly, if it's not enabled, then we don't want to. So if it's not already enabled, we don't want to disable it. We're going to go with the Gpio Unit type def. And basically just set it back to being a standard input pin in the case that we're disabling the external interrupt. So just set it back to normal input. Like so. Also want to go in and make sure that we disable this interrupt as well. Like so. Pop some comments in there. And we also want to keep track of the fact that we've just changed that, so and that is basically what we need to do for that driver. So to try that out, we'll jump into main. We're going to create a class for that. We'll need to include that file in our main. QAD EXTI, and let's just call it EXTI test. We'll make that a pointer to that one. And we're also going to want to be able to set a handler method or a callback function for the handler so that it actually triggers when we go to trigger the interrupt. So let's just create this up here for the moment. And we're just going to go, let's call it EXTI test handler. And I'm going to set this function up the way we've defined it in here. So where we defined our function pointer. So returns a void, gets given a void pointer called pdata. The name doesn't necessarily have to be the same, but the data types that it's getting handed and returning need to be the same. in order for it to work correctly. And what we're going to do, similar to what we did before, is if that triggers, we're going to get it to let us know about that. Like so. So now that we've got that bit done, we can go in here and go QAD EXTI, and then we need to pass it our port and pin so that it knows which one we're setting it up for. I wanted to set our handler function to EXTI test handler, so the name of the function that we've created up here. So that way that's set, so it knows to call that when the interrupt gets triggered. And then once we've done that, we can enable it. And for this one, got to tell it what edge we're going to go with. So we're going to go with our rising edge. Like so. Make sure I'm not forgetting anything for that one. I think that should be all good there. One thing we will need to do though, in order for that to trigger correctly, is we need to go into our handlers here. I'm going to create an extern for this one so that we can access this EXTI test class that we've created from inside the handlers file. Go down to this one here and we'll get rid of this code and just go EXTI_test and call the handler for that one. We will also need to include our QAD EXTI file there as well, just so that that all works correctly. Let's see if that wants to build for us. Some errors there somewhere, 16 errors. Actually, that will be nothing in there. Okay, got some errors in here. So we also need to add in an enum that I haven't popped in here yet. So that's for our init state. No, that's the next one's for our init state. And we'll create one for active state. Call that inactive and QA active. So that'll fix that particular error. What's this one? Ah, okay, same reason. So let's build that. It's possibly taken care of a bunch of those errors. One left over though. What have we got there? Ah, missing an underscore there. There we go. Excellent. 0 errors, 0 warnings. Let's see if... Nope, that one GitHub. Let's see how we go with this. Okay, so it's booted. And the interrupt is triggering correctly. If we jump to this one, and see, you'll notice sometimes you press it once and it'll trigger twice. It's basically just due to switch bouncing. So because we're dealing with a mechanical switch, sometimes when you press it, the contacts can bounce. So in that case, it'll register as two actual rising edges, which then triggers the interrupt twice. ST does do a pretty good job of actually debouncing the switches in their circuits. Pretty sure they use capacitors or a resistor capacitor in there to act as a bit of a filter, which is why most of the time it's just going to trigger once. However, like that time, then you'll occasionally get it where it's triggering twice. So worth being aware of that. If that's happening, then that's why. It's unfortunately the mechanics of the switch itself. However, let's see if we jump back in here. Let's change this to both edges, which means that for each press we should actually get 2 triggers. We'll make sure that that actually works correctly as well. Hopefully so. And in this case, if it bounces, we're likely to get more than 2 triggers showing up per press. So it's 2, 2, 2. So pretty consistent. And we're not getting extra... I think we might have just got a 3rd trigger on that press, but for the most part, that's working too. So we're getting a trigger when we press it and a trigger when we release it. So that part's working as well. So that's basically the simple approach to getting external interrupts done. Again, I find that way simpler than doing it using the actual EXTI HAL driver, because it's just a matter of setting up the GPIO and the interrupt, and away you go. Be aware that if you are using external interrupts, then you will find that, say, if you want to use pin 0 of GPIO A and pin 0 of GPIO B, so pin 0 of both of those, that they are going to share the same interrupt. So in that situation, I'd probably avoid doing that. In that case, if you are able to, I'd probably use, say, GPIO 0, pin 0 of GPIO A and pin 1 of GPIO B, so that you're actually using 2 different ones. It doesn't matter so much with the shared interrupts from pins 5 to 9 and from 10 through to 15. Although same thing, I wouldn't use pin 9 on GPIO and GPIO B. I'd try and go with different ones. So if you use pin 8 of GPIO A and pin 9 of GPIO B, that's still going to work fine, even though they're using a shared interrupt, because when we go into the actual driver code, when it's doing the interrupt part, it's actually doing it based on what pin it's using. So try to avoid putting external interrupts where they're using the same pin number. So you can use different GPIOs. That's not a problem at all, but try to avoid sharing pin numbers. If anyone has any questions about any of this stuff, feel free to leave a comment on YouTube. And jump onto our subreddit, so r/ones and zeros, or there is also an email address which is going to come up at the end, contact.onesandzeros@gmail.com. If you've got any questions or anything like that, or anything that you'd like us to look at in a future video, definitely feel free to let us know about that. love getting into sort of different bits and pieces with these devices, so more than happy to have a look at that sort of stuff. If you have enjoyed this, would love it if you followed us on Twitch or gave us a like and subscribe on YouTube. Definitely means a lot. And if you want to help the channel moving forward with some of the content that we're looking at doing, even getting some of the streaming equipment set up a bit better, we do also have a Patreon, and there will be a link visible coming up shortly as well. So thanks very much for this one, and hope you look forward to the next one, where we're going to be taking a look at doing some of the different stuff that we can do with timers. So starting with just using timers with interrupts, and then we're going to be doing some stuff with encoders and some stuff with pulse width modulation, as well as getting into analog to digital converter stuff after that. There will also be another episode of our Discovering STM32 series coming out, hopefully in the next couple of days as well. So thanks very much for watching. Hope you have a great day or night or whatever it is where you are. Thanks.